Okay, Algebra 1, continuing with this consecutive even problem. Remember that when you set these up with consecutive even, you're going to do n as your first one, and then n plus 2 as your second one, and then if you have a third one, n plus 4 as your third one. And in this problem, it was all three of them added up to equal 42. The sum of them all was 42. So I'm just going to show all of these being added. So n plus 2 plus n plus 4 equals 42. Then we will combine like terms. So n plus n plus n is 3n, and then 2 plus 4 is 6, and equals 42. Subtract the 6, and you get 3n equals 36. Divide them both by 3, and your number is equal to 12. So that's your first number. Then your second number would be that 12 plus 2, so 14. And then your third number is 12 plus 4, so 16. So these are your three consecutive even numbers, 12, 14, 16. Let's look at another example. Okay, now this one is doing consecutive odd integers, and the common mistake is to think, well, since even integers, when you do even, it's n plus 2, n plus 4. When you do odd, it would be n plus 1, n plus 3, but that's incorrect. Because think about if you had a number and it was equal to 5. Then the next odd number would be 7, and that would mean we'd have to go n plus 2 to equal 7, 5 plus 2, because when you're doing odd numbers, you're skipping by 2 anyway. So you're still going to use n plus 2, n plus 4 when you're doing three of them. So I'm going to leave those there. So here's my first one, my second one, and my third one. And the way the problem will work out is because of the numbers that are used in the problem, it will work out that there are three odd ones if it's supposed to be odd. And remember, integers means no fractions. So on these ones that you're doing consecutive integer, consecutive even integer, or consecutive odd integers, if you get fractions, you've made a mistake somewhere. Okay, so let's look at what we're going to do with these. It says 5 times the sum of the first two. So 5 times the sum of the first two. That means I need to add the first two numbers here. So n plus 2, and then I'm going to be saying that times 5. Okay, is this my equals? And it says it is the same as 8 times the third. So now I'm going to say 8 times whatever my third number is, which is n plus 4. So that's how I set it up. Again, it said 5 times the sum of the first two. So 5 times I've got to add something together before I can multiply 5 by it. So my first one is n, my second number is n plus 2, so I'm showing them being added together, and then we'll combine like terms in here and then distribute the 5. And then is the same as equals, and then it says 8 times the third, and since my third is n plus 4, I'm going to put that in parentheses and show 8 times that. So let's do some combining like terms right here. And we get 5 times 2n plus 2, and then 8n plus 4. And now we'll distribute here, here, and then on this side as well. So we'll get 5 times 2n is 10n, 5 times 2 is 10, 8 times n, 8n, and then 8 times 4 is 32. So now we'll move this smaller n over here, and we'll get 2n plus 10 equals 32. So now subtract 10 from both sides, and I'm going to write it over here. You get 2n equals 22. Dividing them both by 2, you guys can see this, n equals 11. Now look at there, it's an odd integer. So if the first number is 11, then the second number is n plus 2 right here. So the second number is 13. And then the third number is n plus 4, so 11 plus 4 is 15. And we have three consecutive odd integers. Okay, so let's do one more odd integer problem, just to make sure we know how to do it. We're doing 3 again, so 3 consecutive odd integers, and I'm just going to stop there and set it up. So my first one is n, my second one is n plus 2, remember odd is still just skip counting by 2, and then my third one is n plus 4. Okay, so 1, 2, 3. Sometimes that helps since we're saying sum of the second, 3 times the third. Okay, so we're going to be adding something. We're going to be summing the second one and then 3 times the third one. So the second one is n plus 2. And then I have to show I'm going to add that to 3 times the third one. So 3n plus 4. And that equals 4 less than twice the first. Remember, when you have a less than, that goes after whatever it's less than. So I'm going to write minus 4 over here. And what it's less than is twice the first. So that means 2n. Okay, so I hope everyone understands how I set that up. Remember, the sum of the second and 3 times the third means we have to add them together. So here's the second again at the n plus 2. And then I'm going to add it. There's my summing. And then 3 times the third. Here's my third, and I've got to do distributing before I can add them together. And then over here, 4 less than. Remember, those less thans have to go after. If you don't put them after, you'll be making a mistake. Twice the first means 2 times the first number, and then minus 4. So let's work this out. So we'll distribute here, and we get n plus 2 plus 3n plus 12, and then equals 2n minus 4. We'll combine like terms on the right side, or left side, and we get n plus 3n is 4n, and then 2 plus 12 is 14, equals 2n minus 4. Now let's move this 2n over to this side, and we get 2n plus 14 equals negative 4. And then we'll subtract 14 from both sides, and we end up, I'll move this down here, 2n equals, and negative 4 minus 14 means we're going to add because the signs are the same, and we get negative 18. We divide by 2, and so n equals negative 9. And you're thinking, can we have negative numbers? Well, think, it asks for 3 odd integers. Integers include your negatives, so it's perfectly fine. So now we'll look at, if n is negative 9, then n plus 2 would be negative 9 plus 2. So that would be negative 7. And then n plus 4 would be negative 9 plus 4, which would be negative 5. So our 3 consecutive odd integers are negative 9, negative 7, and negative 5. And that makes sense because the opposite of whole numbers are your negative integers. And that's it. If you guys have any questions, of course, you can text or email me later tonight, and I'll be happy to help you. Mr. Gungle knows what he's doing, so he'll be able to help you with these as well. And I'll see you guys tomorrow. Thanks, Mr. Gungle, for helping out today. Bye.